Assalamu alaikum warahmatullahi wabarakatuh, and hello everyone. Okay, so today I'm going to give you some help and hints on the questions on exercise 19.1. Okay, so let's start. The first question, so you're given the list of different carboxylic acids and their pKa value. Okay, so one thing that you need to notice or take note is that pKa value is the same as pH value. The lower the pKa, the lower the pH, the more acidic it is. Okay, so you can see based on the value which one is more acidic. Now, another thing that I want you to take note is that all of them have the COOH group. Okay, so if you want to compare the acidity between acid 1 and 2, you cannot talk about the COOH because both of them have the same functional group. Okay. Before we look at the explanation on the difference in acidity, state the mathematical relationship between pKa and Ka. Basically, this is just writing down the expression. Okay, so if you write down, now pKa is derived from pH. Okay, so if this is not, this is just to help you revise back the relationship of P in the pH and the concentration of H plus. Okay, now in the case of Ka, all you have to do is just change the H to Ka. So pKa is equals to the negative or the inverse logarithm of Ka, or you can write down as Ka is equals to 10 to the power of minus pKa. Okay. Right. Next, let me just clear this page first. Okay. So you want to look at the acid 1 and acid 2. Okay. So acid 1 is an ethanoic acid, and then acid 2 is a propanoic acid. Okay, so if you want to talk about the acidity, the easiest argument, there are a few arguments or a few explanations that you can use, but the easiest is based on the stability of the anion. Okay, so I will draw it as its carboxylate. Okay, so this is the first acid, which is an ethanoic acid. The carboxylate is ethanoate ion. And the second acid, propanoic acid, the anion is called propanoate ion. Okay, so as you can see, this part of the molecule is the same, okay, where the CO minus is. Right? The only thing that is different between these two molecules is the substituents or the groups on the left side of the molecule. Okay, in which case you have a methyl here and an ethyl here. Okay, one thing that you need to know as well is that alkyl has an electron donating effect. Okay, now it doesn't really donate its electrons fully, just dense electron density. Okay, it pushes some electron cloud or electron density towards the COO minus. Okay, so the only difference between these two is both of them are alkyl. Top one is a methyl, and the bottom one is an ethyl. Okay, so methyl would push some amount of electron density into the COOH, into the COO minus part. Okay, and that is the negative part of the molecule. Now this arrow that I have just drawn here is showing you that the some of the electron density from the methyl is being pushed onto the COO minus. Now if you imagine, COO minus is already a negative species with the methyl group pushing some electron density. If you're negative and someone is pushing negativity to you, you become unstable. Okay, so that's methyl. Ethyl is a bigger group. Okay, it has the same effect, which is electron donating effect. However, ethyl has a bigger electron donating effect. Okay, I draw it as two arrows just to show the relative size. Methyl has a relatively small electron donating effect. Ethyl has a bigger electron donating effect. Okay, so again, the ethyl group is donating a relatively bigger amount of electron density to your COO minus. Okay, so if you want to compare between the anion in number 1 and the anion number 2, both of them are unstable. However, anion number 2 is even more unstable. Okay, because the ethyl group has a bigger electron donating effect onto the COO minus. Therefore, the anion, let's just use a the specific name. So that's the propanoate ion, that's ion number 2, is more unstable. Okay, so that's why acid number 2 is less acidic. Okay, acid 2 less acidic. Right? Remember the idea, the more stable the anion is, the more ionizations will occur. And if more ionization occurs, more acidic it is. Okay, so remember this rule. More stable anions means more ionization means more acidic. Okay, so this is something that you have already learned in your notes. Your answer would be this, to answer that, for 1 mark only. Okay, moving on. How do I add a page to this? There we go. Okay, acid 2 and acid 3. Again, same thing. I know we're talking about acid 2 and acid 3, but I want to talk about the stability of the anion, so I will draw its carboxylate ion. Okay, so for acid 2, I'll use blue pen. I have the same. Okay, so you can imagine there's a hydrogen there, but I'm not going to draw it. You can draw it. There is no, of course, there's no problem if you want to draw it. And then for acid number 3, you now have a chlorine on the second carbon. Okay, so you have to be careful. That chlorine there sits on the second carbon, and there's only 1, 2, 3 carbon. Okay, so they have the same number of carbon. If you look on this structure, 1, 2, 3, 1, 2, 3. Okay, they also have the same COO minus. Both of them is a COO minus anion. The only difference between these two is the chlorine atom on the second carbon. Okay, there is no chlorine atom in your 1, 2, 3 propanoate ion above, which is number 2. Okay, ion number 2 has no chlorine. Ion number 3, there is chlorine. Okay, one thing that you need to know about chlorine is chlorine has an electron withdrawing. Withdrawing. Okay, so this is the opposite to your alkyl group, right? Electron withdrawing, that means it withdraws electrons from the COO minus. Okay, because chlorine is an electronegative element, therefore it takes the electronegativity of this carbon, and as a chain reaction it takes the electronegativity of this carbon and this whole negative charge. Okay, so now what's with chlorine atom? What's the effect of chlorine pulling away electron density? Now you are a negative person, Okay, your friend is removing the negativity inside you. So do you become stable or less stable? Of course, when people are trying to remove negativity inside of you, you become more stable. Okay, so this anion is more stable. As opposed to the anion number 2, you do not have a chlorine to take away your negativity. In fact, you have an ethyl group, which is electron donating. This ion, anion number 2, is very unstable. Okay, so when you look at 1 and 2, okay, 1 is more stable. 2 and 3, 2 is more stable than 3. Okay, so you have to look at them relative to one another. Okay, so to answer this, same thing, you will say that chlorine has an electron withdrawing effect which stabilizes the propanoate ion. I wouldn't call it propanoate ion because it's chlorine. Stabilizes the anion of acid 3. Okay. Right. Next. Acid 3 and acid 4. Acid 3, you have, well, basically the one that we looked at. Again, I'm going to look at the anion only because it's easier to use the stability argument. Okay, for acid 4, you have 1, 2, 3 carbon as well. The only difference is now your chlorine is on the 3rd carbon. Okay, remember for carboxylic acid, the carbonyl carbon will always be number 1. Carbonyl carbon is this carbon that is attached to the double bond O. Okay, that is what we call a carbonyl carbon. Okay, so what's the difference between 3 and 4? They both have the same number of chlorine atoms. The only difference is the distance. Okay, in anion 3, the chlorine is sitting on the 2nd carbon. In anion 4, the chlorine is sitting on the 3rd carbon. Okay, so this is the distance factor. The further away the chlorine is from your COO minus, the weaker the effect of removing electron density. Okay, the nearer your chlorine is to your COO minus, the more electron density is removed. Okay, so if you look at the pKa of 3 and 4, it says that the pKa of 3 is lower, therefore this is more acidic, hence the anion is more stable. Okay, that's true because the effect of the chlorine withdrawing electron density from the CO minus is bigger than if you look at this chlorine. Okay, the arrow is smaller because the chlorine is further away, so it doesn't remove a lot of electron density from the COO minus. Okay, so we will talk about the distance. Distance of electron withdrawing atom or chlorine in acid 4 is further away. Okay, if it's further away, that means the anion is more unstable. Okay, actually I will just erase that because it's confusing. Okay, right, so that's question 1. Moving on to question 2. Okay, so question 2 is a little bit uncommon, okay, but it does come out and it is definitely in your syllabus. So there are two stages. If you look at this equation, this equation is showing you the dissociation or the ionization of a dicarboxylic acid. What is a dicarboxylic acid? A dicarboxylic acid is a carboxylic acid that has two functional group, two COOH, okay, one on the left side and one on the right side, right? And you can even have this. It doesn't matter how many carbons you have in between. That's why in the expression they have used N. Okay, you see the N? The N shows you how many carbons you have in between, how many CH2 group you have in between one COOH group and the other COOH group. Okay, so taking this one as an easy example, okay, for a dicarboxylic acid or a diprotic acid, it means that it can give out two hydrogen ions per molecule. Okay, so if you look at this molecule, you can give out the hydrogen on the left and the hydrogen on the right, right? It doesn't matter. However, this dissociation or ionization happens one at a time. Okay, so that's the main rule. And it doesn't matter which one happens first, left or right, okay? But according to your expression, we will follow removing the hydrogen ions from the right hand side first. You see that negative sign? That is because first stage or first step, and it is irreversible because association, dissociation of a weak acid is reversible. Okay, unless it's a strong acid, then you would have an ionization in a single arrow. Okay, so this is stage 1, where you remove the hydrogen ions from the right side first. Okay, so after you remove the first hydrogen ion, you will get a carboxylate ion with a negative charge. Okay, then the second stage is when you remove the other hydrogen ions, which is on the other side. Okay, so when you remove the other side, you will get COO minus, COO minus. Okay, so essentially this product is a dianion. Okay, we call it a dianion or an anion with -2 charge. Okay, -1 from one oxygen and -1 from the other oxygen. Right. This anion only has a charge of -1. Okay, which is on this oxygen. So they give you the different pKa1. Okay, pKa1 is for this first step, and then pKa2 is for the second step, right? And they also give you for different number of N's. Okay, when N is equals to 1, that means you only have one carbon in between, like this, for example. These are the values. When N is equals to 2, you have CH2, CH2 in between. And when equals to 3, you have CH2, CH2, CH2 in between your carboxylic acid. Okay, like this. Yeah. Okay, right. So that doesn't matter, but the one thing that you should notice from these two numbers is that pKa, removing the first hydrogen ion, is more acidic than removing the second hydrogen ion. Okay, so this has something to do with the stability of an ion. Of course, the pKa value will tell you about the stability of the anion. If your pKa is low, that means you have a high ionization, your anion is stable. For comparison, the pKa of ethanoic acid is 4.76. Okay, so ethanoic acid is not in this question, but they just give you as reference. The pKa is 4.76. Okay, state the mathematical relationship. You know how to answer that already. For part 2, I'm going to go straight to part 2. With reference to the table above, suggest why the pKa1 value. So we're only interested in the first step. Okay, the first step, that is when you remove one hydrogen ions. why the pKa values are all smaller than the pKa of ethanoic acid. Okay, so we want to look at ethanoic acid, and okay, I'm just gonna use this, right? So pKa of ethanoic acid is bigger than all of this dicarboxylic acid. Okay, it doesn't matter if you have n equals to 1, n equals to 2, n equals to 3, but what this is saying is that the dicarboxylic acid is more acidic. Okay, dicarboxylic acid is more acidic than ethanoic acid. Okay, now you have to explain the reason. You can't just say, oh, because it can lose 2 hydrogen ions, therefore more hydrogen ions is being given away or released. But you cannot say that, because if you look at the pKa value, the second one, losing the second hydrogen ions is higher than the pKa of ethanoic acid. So that means losing the second hydrogen ions is not easy. Okay, right. How do you answer this? There's one thing that you do not know yet, but okay, COOH is actually an electron withdrawing group. Okay, so COOH is an electron withdrawing group. Okay, so this brings us back again to the stability of the dicarboxylic anion. Okay, so if I draw this dicarboxylic anion in terms of its dicarboxylate, okay, the COOH group has an electron withdrawing effect. So it withdraws, or it takes away the electron density on the COO minus, making it more stable. Okay, we call this the mono anion becomes more stable than ethanoic acid. Okay, if you look at ethanoic acid versus ethanoic acid, sorry, I've been meaning to change the color, versus ethanoic acid, or I should talk about the ethanoate ion. If you have ethanoate ion, CO minus, and then you have, you have a CH3. CH3 is electron donating group. You are adding electron density to an already negative person. So this is very unstable. Okay, so if you look at the stability of the anions, the more stable anion will be most likely to be formed, more ionization, therefore more acidic. Okay, and from the value of the pKa, it can tell you that compared to this value to the value of, where is it? Ethanoic acid 4.76, the dicarboxylic acid is more acidic. Okay. With reference to the suggest why the pKa values become larger as n increases. Okay, so when you have n equals to 1, okay, this is when n equals to 1. N equals to 2, you have CC, 2 carbon, 2 CH2 in between the two functional group. Okay, n equals to 3 is 1, 2, 3. Why do I talk about the anion? Same reason, because I want to talk about the stability. Okay, remembering that this group is an electron withdrawing group. Withdrawing. Same thing, this one is electron withdrawing, and likewise electron withdrawing. So it says that based on the pKa value, it is saying that n equals to 1 is the most stable, most acidic based on the pKa value being the lowest, and then n equals to 3 is the least stable, or we say it as being least acidic. Okay, the reason, I hope it is obvious, you can see that distance is the reason. Okay, in n equals to 1, the electron withdrawing group is closer to the COO minus group. Okay, this electron, this COOH withdraws, and it is very good at withdrawing because it's quite close to the COO minus. N equals to 2, the electron withdrawing COOH group gets further away. Okay, there's now 2 carbon in between. Okay, and n equals to 3, even further away, there is now 3 carbon in between, so the electron withdrawing group has a very little effect on removing the negativity in the COO minus. Okay, so it's all about the distance, right? You will construct your own answer and sentence. The electron withdrawing group is closest to the COO minus. Okay, making the anion, we call this a monoanion. Monoanion is because it has a positive charge of -1, making the monoanion stable. Okay, this one, electron withdrawing group is furthest away, therefore not much electron density withdrawn, therefore no less stability. Okay. Next one, suggest why all the pKa2 values in the table above are larger than the pKa of ethanoic acid. Okay, so pKa2 is when you are removing the second proton or the second hydrogen ions. Okay, we're removing the hydrogen ion. Now you need to see this in the second stage where your pKa is of pKa2. It is not easy to remove positive things from a negative person. Okay, you want to remove H plus, right? So you think about it, you are removing positivity from a negative person. You do not want to do this. Okay, a negative person wants to hold on to the positivity. You do not want to take it away. Okay, so this ion will become very, very, very unstable. Or the answer to that is, I'll explain it to you later, it is electrostatically unfavorable to remove H plus from a negative ion. Okay, this ion is already negative because you have removed the first hydrogen ions or the first proton. Okay, electrostatically means the charge. Okay, as I said, you do not want to remove a positivity from someone who is already negative. Okay, if anything, you either want to add positivity or you remove the negativity in that person. Okay, so that's that. It is electrostatically unfavorable to remove H plus from a negative ion. Okay, for question 3, tartaric acid has 2 dissociation constants, same thing, because you will remove the first hydrogen ions first, that's your Ka1, okay, and then you remove the second one, which is Ka2. Okay, so you have to think, the first one, K1, is 2.99. That means it's not easy, but I would say easy to remove the first H plus, okay, and then K2 is 4.40, okay, not easy to remove the second H plus. The reason is the same as the previous one. You have to explain. This is not the answer. This is just giving you some hints. Okay, so you have to write down the equation that is corresponding to K1 and K2. K1 is removing the first H plus. K2 is removing the second H plus. Please use the previous question as a guidance. Okay. Question 4 is not too bad as well, but I'll draw it out for you just in case you cannot see it. COOH, COOH. So this is again a dicarboxylic acid, and you want to convert it to a acyl chloride. Okay, so this is a diacyl chloride. So you have changed the OH to Cl on both sides. So you need to find a suitable reagent for this reaction. You know how to convert carboxylic acid to an acyl chloride. Please look it up on your notes. Part 2. For the reaction of ethane diol chloride below, suggest the structures of compounds J and K and draw them in boxes. Okay, so for the first reaction, which is the reaction on the left, okay, you have a C double bond O Cl, C double bond O Cl, okay, and then you are reacting it with alcohol. Okay, so alcohol plus acyl chloride. Please look it up on your notes. Remember that this alcohol can react on both sides of the molecule. Okay, please look it up on your notes. I will not tell you. The next one is the equation on the right. Okay, same thing. C double bond O Cl, C double bond O Cl. Now the only difference for this reaction is that you have a diamine, NH2 and H2. Now you have two regions as well for the diamine. Okay, so one side of the nucleophile, okay, so this is a nucleophile. One side of the nucleophile will react with one side of the diacyl chloride. The other side of the nucleophile will react with the other side of a diacyl chloride. So the answer would be a cyclic ring product. Okay, so this is the same as acyl chloride plus amine, but it's a little bit twisted because you have a diamine. Two nitrogen atoms can attack to your diacyl chloride. Okay, and it will give you the cyclic or the ring product. Okay, so that's question 1, 2, 3, 4 for you to do. I'll continue giving you hints for question 5 and 6. Okay, Assalamualaikum. Thank you.